Good day, students! In this video, you will learn how to graph a logarithmic function. Please watch it thoroughly because this will be discussed to you in a step-by-step manner. So without further ado, let us discuss example number 1. In example number 1, we have the given of y is equal to the logarithm of x minus 1 with the base 3. In step 1, we must equate the expression of the logarithm so that we can come up with whole numbers that can easily be plotted in our Cartesian plane later. So to do that, you need to follow this procedure. First, we will equate our expression of the logarithm, which in our example that is x minus 1, and we will equate x minus 1 to 0 in order for us to locate where our vertical asymptote lies. Next, we will equate the expression of the logarithm to 1. This is because the logarithm of 1 given any base is equal to 0. And last, we will equate the expression of the logarithm to its base because logarithm of 3 with the base 3 is equal to 1. And we will find the values of x that these equations will produce. So when x minus 1 is equal to 0, apply APE and it will give us x is equal to 1. Next, x minus 1 is equal to 1. Apply APE and it will give us x is equal to 2. Next, x minus 1 is equal to 3. Apply APE and it will give us x is equal to 4. And these values will be used in our table of values later. Next, in step 2, we will be needing to complete the table of values. Remember that in order for us to graph, we need coordinates. And in this process, we will find those coordinates. So for our x values, we will put the computed values earlier, which are 2 and 4. 1 will not be included in table of values for x is equal to 1 is our vertical asymptote. Now, we will find the corresponding y in each x. So we will go back to the given y is equal to the logarithm of x minus 1 with the base 3, and we will substitute 2 in our x. That will be y is equal to the logarithm of 2 minus 1 with the base 3. And then solve for y. We will have the logarithm of 1 with the base 3. Remember that logarithm of 1 given any base is equal to 0. Therefore, our y is equal to 0. And that is the corresponding y value if we use 2 as our x. Next, let's go back to the given and try substituting 4. So it will become y is equal to the logarithm of 4 minus 1 with the base 3. Then solve for y. Y now is equal to the logarithm of 3 with the base 3. Remember that the logarithm of 3 with the base 3 will be equal to 1. And that is our y. 1 will be the value of y if we use 4 as the value of x. Remember that you could always locate or solve for more coordinates than this. So the step 3 will help you decide. We will find the domain and range so you'll have a guide as to what values of x will satisfy our given function. To solve for domain, we must take the expression of the logarithm and determine where the value is greater than 0. Then solve the inequality. Apply APE and we will have x is greater than 1. So the domain will be x such that x is greater than 1, whereas the range will always be an element of real number. Therefore, if you will be picking for values of x to be substituted in the given function, it must be greater than 1. Before graphing, step 4 is needed because this will name other points from the graph. That is to solve for x and y intercepts. To solve for x-intercept, we will let y be 0. On the other hand, for solving y-intercept, we will let x be 0. So we will go back to the given function, y is equal to the logarithm of x minus 1 with the base 3. Next, we will substitute 0 to y. So the equation now will be 0 is equal to the logarithm of x minus 1 with the base 3. Through the property of equivalent equation to exponential form, our given equation will now be 3 raised to 0 is equal to x minus 1. Then we will simplify. 3 raised to 0 is 1, and on the right side we have x minus 1. Apply APE to solve for x, and we will get 2 is equal to x, similar to x is equal to 2 through symmetric property. And therefore, our x-intercept will be 2, 0. Now, for y-intercept, get the given function again. So that is y is equal to the logarithm of x minus 1 with the base 3. Then substitute 0 to x. That will become y is equal to the logarithm of 0 minus 1 with the base 3. Then solve for y. We will have y is equal to the logarithm of negative 1 with the base 3. And we all know that the logarithm of a number cannot be a negative number, for this will give us an imaginary number. With that, we can say that there is no y-intercept in this given function. Now, in step number 5, we will plot all the points that we got earlier. So those are 2, 0, 4, 1. But before that, we will plot first the vertical asymptote. Our vertical asymptote is at x is equal to 1. And that corresponds to the green line. Next, let us plot 2, 0. As you can remember, that is also our x-intercept. Next, 4, 1. And then, let us sketch the graph. And that will go infinitely to both directions. And that is now the graph of our given function y is equal to the logarithm of x minus 1 with the base 3. Let us now proceed to example number 2. We have the given function y is equal to the logarithm of 5 minus x with the base 4. So, in our step 1, we will equate the expression of the logarithm so we can come up with whole numbers that can easily be plotted in our Cartesian plane later. So, we will name the expression of the logarithm in our given, that is 5 minus x, and we will equate that to 3 different numbers. First, we will equate 5 minus x to 0 so that we will be able to locate where our vertical asymptote lies. Next, we will equate the expression to 1 because the logarithm of 1 with any base is equal to 0. And last, we will equate the expression 5 minus x to its base, which is 4, because logarithm of 4 with the base 4 is equal to 1. And now, we will solve these equations. So 5 minus x is equal to 0. Apply APE. We will get 5 is equal to x, similar to x is equal to 5. Next, 5 minus x is equal to 1. Apply APE. So we will add positive x to both sides. And it will be 5 is equal to 1 plus x. APE. add negative 1 to both sides, and we will have 4 is equal to x, similar to x is equal to 4. And lastly, we have 5 minus x is equal to 4. Apply APE by adding positive x to both sides. We will have 5 is equal to 4 plus x. Apply APE again by adding negative 4 to both sides. So it will give us a value of 1 in our x, similar to x is equal to 1 through symmetric property. Next, for step number 2, we will be needing to complete the table of values. Remember that in order for us to graph, we need to have coordinates, and in this process, we will find those coordinates. So we will put the computed values of x that we have earlier, which are 1 and 4. 5 will not be included because x is equal to 5 is our vertical asymptote. And now, let us find the corresponding y value in each x. So let's go back to the given. We have y is equal to the logarithm of 5 minus x with the base 4. Substitute 1 to x. We will have y is equal to the logarithm of 5 minus 1 with the base 4. Then solve for y. We have now y is equal to the logarithm of 4 with the base 4, and definitely that will be 1. 1 will be the value of y if we use 1 as our x. Next, let's have the given again. Y is equal to the logarithm of 5 minus x with the base 4, and this time substitute 4 to x. So it will be y is equal to the logarithm of 5 minus 4 with the base 4. So that would be y is equal to the logarithm of 1 with the base 4. Again, logarithm of 1 with any base is equal to 0. Therefore, y is equal to 0. So the value of our y will be 0 if we use 4 as x. Remember, you could always locate or solve for more coordinates than this. So the step 3 will help you decide for that. We will solve the domain and range, so you'll have a guide as to what values of x will satisfy our given function. So again, let us get the expression of the logarithm and determine where the value is greater than 0. So that would be 5 minus x is greater than 0. Apply APE. So we will have 5 is greater than x. So the domain will be x such that x is less than 5. Whereas the range will be the element of real numbers. Therefore, you could pick any numbers for x. However, it must be less than 5. Before we proceed to graphing, step 4 is needed because this will name other points from the graph. That is to solve for x and y intercepts. To solve for x-intercept, we will let y is equal to 0, and to solve for y-intercept, we will let x is equal to 0. So let's have the given y is equal to the logarithm of 5 minus x with the base 4. Substitute 0 to y, that would be 0 is equal to the logarithm of 5 minus x with the base 4. And through the equivalent equation to exponential form, we will now have 4 raised to 0 is equal to 5 minus x. Then simplify. 4 raised to 0 will be 1 is equal to 5 minus x. Then apply APE. We will now have 1 minus 5 is equal to 5 minus 5 minus x. That will become negative 4 is equal to negative x. Then multiply negative 1 to both sides of the equation. We will now have 4 is equal to x, similar to x is equal to 4. Therefore, our x-intercept will be at 4, 0. Let's proceed to y-intercept. let's have the given y is equal to the logarithm of 5 minus x with the base 4. Substitute 0 to x, we will have y is equal to the logarithm of 5 minus 0 with the base 4. Then simplify, we will have y is equal to the logarithm of 5 with the base 4. Since we know that logarithm of 5 with the base 4 will give us a number in a decimal form, we will just write it as logarithm of 5 with the base 4. Therefore, our y-intercept will be 0, logarithm of 5 with the base 4. Lastly, step 5, we will now plot all the coordinates that we solved earlier. But first, we will plot the vertical asymptote, which can be found at x is equal to 5. That is the green line. Then we will plot the coordinates 4, 0. As you can remember, that is also our x-intercept. Then 1, 1. And let us sketch the graph. And that is now our function y is equal to the logarithm of 5 minus x with the base 4. Please note that the intersection of our graph and the y-axis is our y-intercept, located at 0, logarithm of 5 with the base 4.